Thank you. Today is January 22nd, 2020. Okay. Today we are simplifying radicals, and we've done this before. We've done it with square roots. So, like I've asked you before, what's the square root of 50? Ooh, interesting. It's been a long time, hasn't it? So let's refresh our brains. The square root of 50, what is the number in the index here? 2. So what I want to do is actually break apart 50 into, I know, two things that it multiplies to be. What times what is 50? 25 times 2. Very good. And then it's also true that 25 is 5 squared times 2. So it turns out that I can rewrite 50 as 5 squared times 2. And I can even check that on my calculators if I was so inclined. 5 squared times 2 is, in fact, 50. All right, so that's nice. Well, then, when my index and the power match, it's pretty easy to say, hey, what's the square root of 5 squared? What happens to the square root and the square? They undo one another. So the square root of 5 squared cancels out and leaves behind a 5 that escapes. Can I take the square root of 2? Nope. So it stays underneath. So we get 5 radical 2. I think before we said, hey, what's the square root of 25? And you would tell me it's 5. So the same is true for something like a cube root. If I asked you what's the cube root of 27, well, we could try and simplify 27. What times what is 27? 3 cubed. Again, you can see 3 to the 3rd power is 27. So what's the cube root of 3 cubed? Just 3. The cube root and the cube cancel out. They undo one another, and we're just left with 3. Okay. So today we are taking roots, all different kinds of roots. We're taking square roots, we're taking cube roots, 4th roots, and 5th roots. And it all comes down to breaking things down. So I want to remind you what prime factorization is. Because I think this is probably the best way I can explain this. If I have a number like 48 and I want to write it in its prime factorization, that means break it apart. 48 is what times what? 6 times 8 is 48. Those numbers break down further, don't they? 6 becomes what? Yeah, 3 times 2 or 2 times 3. And what can we do with 8? 4 times 2. Do any of those go down further? Do they break apart more? 4 does, right? So we have 2, we have 3, and then 4 becomes 2 times 2. And then we still have that. This is the prime factorization where we break everything down into primes, like 2, 3, and 5. And then I can write it as 2 to what power? 2 to the 4th power times 3. This, ladies and gentlemen, is the prime factorization. And I think probably that's where we want to go today, is figuring out prime factorizations first. And then from there, we'll talk about roots. So let's see how this works. This is kind of interesting. So prime factorization, we're going to do lots of that today. Here we go. Example 1, simplify. Use absolute value signs when necessary. Use absolute value signs when necessary. It's very, very, very important. You see I have here the square root of x squared. What's the number in the index? 2. What is the square root of x squared? So you know when we're like solving, it's just x, yes. The square root and the square cancel one another out. They undo one another, just leaving behind x. But it turns out today, when we take the square root of a number squared, we want to remember that it's actually going to be the absolute value of the number. Because I don't know what x is. X could be any number. It could be a positive number. It could be a negative number. It turns out when we run into this situation, the number has to turn positive for a weird reason that I could talk to you individually about. But for now, we're just going to accept that the square root of a number squared is absolute value. Which also says the fourth root of x to the fourth. What's the fourth root of x to the fourth? It's x with absolute values. Again, the fourth root to the power of 4 undo one another, just leaves the x. What's the sixth root of x to the sixth? Absolute value of x. Yes, it is. What's the eighth root of x to the eighth? Absolute value of x. Yes, it is. Okay. It turns out I really only care about absolute value if we have an even index and x to that even power. So the even root of x to an even power is always going to be absolute value of x. Does it matter when it's odd? No, I don't care about that. The cube root of x cubed turns out just x. Much easier. It's when things are evens that even powers make everything weird. Okay. All right. So this is the rule we're going to look out for today. And I'm going to walk you through how to simplify these things. And it's going to seem quite weird. But I want to start with the square root of 96 here. I want to break apart 96 into its prime factors. When you look at 96, what is it divisible by? 3 and 2, actually. How do you know it's divisible by 2? It's even. Sure, it's an even number. It must be divisible by 2. How do you know if it's divisible by 3? The digits. The digits add up to be a number divisible by 3. So 9 plus 6 is 15, and 15 divides by 3 evenly. So it turns out that 96 is also divisible by 3. So let's see. 96 divided by 3 is 32. So it turns out that 3 times 32, that's good. Is this the prime factorization or does it go further? Oh, it totally goes further, right? 32 is 16 times 2, sure. All right. Are we done? No, 16 goes further, right? What is 16? 4 times 4. Okay, 4 times 4. All right, are we done yet or do we still have to go further? Still got to go further, right? Okay, so 4 is, now hopefully you can get faster at this, but we're taking our time. 4 breaks apart into 2 times 2. Please be careful that you don't leave any factors behind. So I want to just double check this to make sure I've got everything. 3 times 2 times 2 times 2, oh God, times 2 times 2. Is that right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 96. Oh, good. I did it right. So I can write this as the square root of 2 to what power? 2 to the 5th times 3 times x to the 5th times y squared. Now that's fine. If you can get that far, you're doing very good. Now here's what we're going to do next. Because I know that the 6th root of x to the 6th is x, and the square root of x squared is x. I want all my powers to match whatever my index is. What's the number in the index here? 2. So it turns out that I can sort of expand this to help myself out a little bit. So I'm going to do a little bit of magic here. 2 to the 5th is 2 squared times 2 squared times 2 to the 1st. Why? The powers add, sure, yeah. So 2 plus 2 is 4, plus 1 gives me 2 to the 5th. Okay. Now I'm choosing 2's because that's what my index is. I want as many 2's as I can get. I can't do anything with the 3. It's just 3 to the 1st power, so I'm going to leave that there, 3 to the 1st. So that one's there. All right, let's see. Let's see. I have x to the 5th. How could I expand that? X to the 2nd times x to the 2nd times x to the 1st. Awesome. And again, 2 plus 2 plus 1 is 5. All right? Now, this is the long way to do it, just so you're really seeing. All right. Oh, hey, y squared is already y squared. I like that. That's a good one to keep. Why do I want to keep that one? It's already a 2. It matches. Okay, cool. So now I can answer the question, what's the square root of 2 squared? What's the square root of 2 squared? 2. Yeah, so a 2 escapes. Whoop. What's the square root of 2 squared? 2. Sure, 2 escapes. What's the square root of 2 to the 1st? Can I do that one? Can't do that one. It's not big enough. Doesn't have a high enough power. So that one has to stay under the radical. What about 3 to the 1st? Can I take the square root of 3 to the 1st? No, that one has to stay. What about the square root of x squared? X, is it just x? Ooh, tricky, absolute value of x. Ooh, right there, the square root of x squared is absolute value of x. So that one got to escape. What's the square root of the next one, x squared? Absolute value of x. What about the square root of x to the 1st? Can I do that one? Nope, that one stays. And what about the square root of y squared? What's the square root of y squared? Absolute value of y. Yeah, absolute value of y. All right, this is a pretty good answer. We can clean it up just a little bit. First of all, inside my radical, 2 times 3 is 6x. On the outside, I can multiply the 2's together, so 2 times 2 is 4. Now, this is really tricky. If you put absolute value of x times absolute value of x, that's wonderful. Okay? What does absolute value mean? It's always positive. If you evaluate with absolute value, it means that what comes out is always positive. Well, it turns out that x times x is x squared. And if I take a number and I square it, it also is always positive. So do I need the absolute values then? They're kind of what we would call superfluous. They're not really, really necessary. So if you've got a couple of them, a pair, an even numbered inside absolute value, then we don't really need those absolute value. However, I only have one of the y's, so that does need absolute value. That's kind of tricky. We'll do another one of those so you can see how it comes together again. Kind of weird. Kind of weird. All right. Letter B is kind of similar, except it's got a negative. So what I'm going to do is I'm going to look at the prime factorization of 108. I'm going to deal with the negative in just a little bit. 108 is what times what? Hmm, 108. Is it divided? Does it divide by 4? Oh, it does. It divides by 2, and it would divide again by 2. I'm going to use 4 times 27. So, interesting. So 4 times 27. And I know that 4 breaks apart into 2 times 2. And what does 27 break into? 3 times 9. And 9 breaks apart into 3 times 3. Okay, so 27 is 3 times 3 times 3. And so my index is 3. All right, I have a negative. I'm going to leave that. Can I leave it as a -1 for now? Times 108. It turns out that 108 is 2 squared times 3 cubed. And if I can check that, if I wanted to make sure, -1 times 2 squared times 3 cubed, hopefully is -108. Ah, it is. Okay, so all of this is the same as -108. What can I do with x to the 7th? Thinking about my index of 3 here. Can rewrite it as x to what power? X to the 3rd times x to the 3rd times x to the 1st. Very good. 3 plus 3 is 6, plus 1 is 7. Good. What can I do with y to the 9th? Y to the 3rd times y to the 3rd times y to the 3rd. Good. 3 plus 3 plus 3 is 9. All right, that's kind of crazy, right? So here's where this is weird with negatives. What's -1 cubed? -1, yeah? -1 times -1 times -1 is -1. So it turns out that I can pretty easily take the cube root of -1. What is the cube root of -1? Just -1. Okay, nice. Because -1 is the same as -1 cubed. The cube root of -1 cubed is -1. The cubes cancel out. Okay. Can I do anything with the cube root of 2 squared? Its power is too small. So that 2 squared is going to stay underneath. What can I do with the cube root of 3 cubed? What's the cube root of 3 cubed? Just 3, that comes out. What about the cube root of x cubed? What's the cube root of x cubed? I heard absolute value of x. I only care about absolute value when they're even. Yeah, so actually this one's easy. It's just x. Kind of nice. What's the cube root of x cubed? X. Can I do the cube root of x to the first? No, that one's too small. It stays inside. What about the cube root of y cubed? Y comes out. Cube root of y cubed. Another y. And the cube root of y cubed. Another y comes out. So I have a negative times 3. So negative 3. X to the second times y to what power? Y to the third. Times the cube root. 2 squared is the same as 4x. So this is our final answer for that one. Okay. What's the relationship between my cube root and my power? You see a connection between those? Look at the cube root and 9. We got 3. Huh, there is something there. Pay attention to. Here we go. Let's try some more. Hopefully they'll get a lot faster. The fourth root. So I'm paying attention because this is an even root. And if I have an even root, then I need to look out for absolute value. Okay. So we have the fourth root of 224. X to the fifth, y to the ninth. What should I do? Break down 224. Okay, let's see. 224. It seems kind of big. I know it's divisible by 2 and another 2. All right. So let's see. It looks like 224 is divisible by 4. All right. 4 times 56 is 224. I can break apart the 4 into 2 times 2, and the 56 can break apart into 8 times 7. So 7 times 8. Are we done, or do we need to go a little more? So the 8 can go a little bit further. 8 is 2 times 2 times 2. So I can rewrite this as 2 to what power? 2 to the 5th times 7 times x to the 5th times y to the 9th. All right, so that's the prime factorization of that number 224. My index is 4. So I want to rewrite things using that power. So what can I do with 2 to the 5th? 2 to the 4th times 2 to the 1st. Good. This is 7 to the 1st. I can't do anything with that. What can I do with x to the 5th? X to the 4th times x to the 1st, yeah. And what can I do with y to the 9th? Y to the 4th times y to the 4th times y to the 1st. Because then they have the same base, you get to add the exponents. So 4 plus 4 is 8, plus 1 is 9. All right, and now we can find our roots. Remember, this is an even root, so we have to watch our absolute value. What is the fourth root of 2 to the 4th? 2 comes out. Yay. What about the fourth root of 2 to the 1st? Can you do that one? Nope, can't do that one. So 2 to the first stays inside. Can I do the 4th root of 7 to the first? Can't do that one either. Power is too small. What about the 4th root of x to the 4th? Absolute value of x. Very good. Can I do x to the first? No. That one stays underneath. What about the 4th root of y to the 4th? Absolute value of y. Very good. Another 4th root of y to the 4th is another absolute value of y. And then y to the first stays underneath because his power is too small. All right, if you have this as your answer, that's really good. But it can be cleaned up a tiny bit. What is 2 times 7? 14. So 14xy underneath. And we have a 2 out here. Absolute value of x is going to stay, but here I have a pair of absolute value of y's. What is y times y? Y squared. So I don't need the absolute value on that one because I'm going to square it and it'll be positive anyway. All right, last one. What's the number in the index? 2, yes. And again, because it's an even index, we're going to look out for absolute values. If it's odd, I don't care about absolute values. That's kind of nice. What does 98 break apart into? I know it's divisible by 2. 2 times 49. And then 49 breaks apart into 7 times 7. All right. So we have the square root of 2 to the first times 7 squared times x cubed times y to the 7th. And I'm going to expand everything. I want to find as many powers of 2 as I can. Can't do anything with 2 to the first. What? Oh, 7 squared is already there. That's nice. What can I do with y cubed? Or sorry, not y cubed, x cubed. X squared times x to the first. Good. What can we do with y to the 7th? Y squared times y squared times y squared times y to the first. 2 plus 2 plus 2 is 6, plus 1 is 7. Okay. All right. And so now we can see what escapes and what stays. What should I do with 2 to the first? That one stays inside. What's the square root of 7 squared? 7 comes out. What's the square root of x squared? Absolute value of x. Good. The square root of x to the first stays inside. The square root of y squared comes out. Absolute value of y. The square root of y squared again, another absolute value of y. And again, the square root of y squared, absolute value of y. Y to the first stays inside. And so just cleaning this up a tiny bit here, we have the square root of 2xy underneath our radical, our square root. 7 is fine. Absolute value of x is fine. I'm curious what I should do with all these y's, though. Do I need the absolute value or not? Yes, you do, actually. Why?
Because it could still be negative.
It could still be negative. Yeah, so if I have a number cubed, if I have like -2 cubed, -2 times -2 times -2 could give me a negative result. we're forcing that to say you have to be positive. Okay.